Hello, and welcome to this video about the second fundamental theorem of calculus. We will explore what this part says and how it works, but first a refresher of the first part. If f of x is continuous on the closed interval ab, and the integral of f of x dx equals big F of x on the closed interval ab, then the integral from a to b of f of x dx is equal to big F of b minus big F of a. Let's get right to it. The second part of the fundamental theorem of calculus is closely related to the first, and it says, if f of x is continuous on the closed interval ab, and the function big F of x is defined by the integral from a to x of f of t dt, then big F prime of x is equal to f of x over the closed interval ab. The biggest implication with this part is that it guarantees that every integrable function has an antiderivative. Notice how big F of x is defined as an integral function. X can be any value and the function will return a number. This is what's called an accumulation function. Let's see how this part of the theorem works. Suppose g of x is equal to the integral from 1 to x of f of t dt. Use the given values of big F of t to evaluate g of x. Big F of 0 is equal to 0, big F of 1 is equal to 2, big F of 2 is equal to negative 3, and big F of 4 is equal to 5. So when we plug in 0, for our function g of x, we're going to have the integral from 1 to 0 of f of t dt, which is the same as saying big F of 0 minus big F of 1, which would be 0 minus 2, which gives us negative 2. If we look at x equals 1, then g of x would be the integral from 1 to 1 of f of t dt, which equals 0, because we're not covering any range. It's the same number on the top and bottom. If we plug in x equals 2, for g of x we get the integral from 1 to 2 of f of t dt, which equals big F of 2 minus big F of 1, which is negative 3 minus 2, which gives us negative 5. And if we plug in x equals 4, then for g of x we get the integral from 1 to 4 of f of t dt, which is equal to big F of 4 minus big F of 1, which is equal to 5 minus 2, which gives us 3. If h of x equals the integral from 2 to x of 3t squared plus 4t dt, then by the theorem we know this. Notice the derivative function is expressed in terms of x instead of t, since the integral function is a function of x. Why is this true? Well, let's take a look. So, to evaluate this integral, we're going to take the derivative of this function, which will give us t cubed plus 2t squared from 2 to x. So then we're going to plug in x for anywhere we see t, so that gives us x cubed plus 2x squared. And we're going to subtract, plugging in 2 for every t that we see. So we have 2 cubed plus 2 times 2 squared, which gives us x cubed plus 2x squared minus 16. And then, remember, this is h of x, so when we take the derivative of this, we'll have h prime of x is equal to 3x squared plus 4x, which is the same thing we found over here. This is especially powerful with more complex antiderivatives like this. Let's get a little practice in. Number 1. If g of x is equal to the integral of negative 5 to 2x of t squared minus t minus 3 dt, find a formula for g of x and calculate g prime of x. Pause the video and try this one on your own. Think you've got it? Let's work it out together. So g of x is equal to 8x cubed over 3 minus 4x squared over 2 minus 6x plus 235 over 6. So now we're going to calculate g prime of x by taking the derivative of g of x. And g prime is 8x squared minus 4x minus 6. Let's try one more. Suppose g of x is equal to the integral of negative 2 to x of f of t dt. Use the provided values of big F of t to evaluate g of x. Big F of -1 is equal to 6, big F of -5 is equal to 0, big F of 2 is equal to 10, and big F of -2 is equal to 4. Now pause the video and give yourself a few minutes to work this out. Ready? When we plug in x equals -1, g of x is the integral from -2 to -1 of f of t dt, which is equal to big F of -1 minus big F of -2, which is equal to 6 minus 4, or 2. Then, when we plug in -5 for x, we get the integral from -2 to -5 of f of t dt, which is equal to big F of -5 minus big F of -2, which is equal to 0 minus 4, or -4. And lastly, let's plug in 2 for x. So this gives us the integral from -2 to 2 of f of t dt, which is equal to big F of 2 minus big F of -2, which is equal to 10 minus 4, or 6. I hope that this video helped with your understanding of the second fundamental theorem of calculus. Thanks for watching and happy studying!